Hello and good morning everyone. In this lesson, we will tackle about measures of variation, z-scores, box and Whisker plot. We are going to define, explain, give examples and situations so that you will understand thoroughly our lesson for today.
Measures of variations can help convey meaningful information about sets of data because variability can provide useful information about data. It's important to know the different measures of variations. Learning about the measures of variations helps you understand how to use this data effectively. Here are some types of measures of statistics that you can use to describe your data. First, range, variance, quartiles, interquartile range, and standard deviation.
Range is the easiest measure of variability to calculate. It is calculated by subtracting the lowest value or score from the highest value in a set. And if the results are large range, then it means it has high variability, since a small range means low variability in a distribution. The formula of range is R equals H minus L, where R is range, H is highest value, and L is the lowest value. In order for us to find and calculate the range, we must first place in order all values in the dataset from lowest to the highest, and the second one is subtract the lowest value from the highest value picked from the dataset. This process and steps are the same regardless of whether the values are positive or negative, or whole numbers or fractions. The interquartile range, or RQR, describes the middle 50% of values when ordered from lowest to highest of a distribution. It is the range for the middle 50% of a certain sample, as well as a way to measure how spread out the data is, and is useful for finding the average. Larger values indicate that the central portion of the data spread out further, and smaller values show that the middle values cluster more tightly. The RQR formula is IQR equals Q3 minus Q1, where IQR is the interquartile range, Q3 is third quartile or 75th percentage, and Q1 is first quartile or 25th percentage. The four simple steps in finding the interquartile range, or IQR, is first, order the data from least to greatest. Secondly, find the median, then calculate the median of both the lower and upper half of the data. Lastly, subtract the media of both upper and lower half of the data. The IQR is the difference between the upper and lower medians. Quartile deviation is also known as a semi-interquartile range and is a measure of a dispersion or variability of a dataset. The quartile deviation is a measure of how far the median of a set of data is from the first, second, or third quartile. It takes the first and third quartiles, which are the 25th and 75th percentiles, respectively, and the quartile deviation is the difference between these two percentiles. The quartile deviation formula is QD equals Q3 minus Q1 over 2, where QD is quartile deviation, Q3 is third quartile or 75th percentage, and Q1 is first quartile or 25th percentage. In order for us to calculate quartile deviation, the first thing to do is find out Q1, then find out Q3, then subtract Q1 and Q3, and lastly divide the result by 2. This is one of the best methods of dispersion for open-ended data. Mean deviation is also called as the absolute deviation. Mean deviation is a type of statistical measure of central tendency, or the average distance from the mean to the scores. The mean deviation is a useful measure for describing the dispersion of data and can be used in a variety of applications, such as calculating variance, as well as comparing two different distributions. To solve the mean deviation for group data, we use this formula, where sigma represents the addition of values, x is the core in the distribution, mn is the mean, and n is the number of observations or data values. Overall, the four steps to calculating the mean absolute deviation, or MAD, are finding the average or mean, then finding the value of the difference between the mean and each data point, and for each difference, take the absolute value, and lastly, finding the average or the mean of the differences found. Standard deviation is a measure of how much variation there is in a set of data. It is calculated by taking the square root of the variance. It tells us about how spread out the data is and can be used to determine the likelihood that any given value will be in a set. Standard deviation is important to use when you're trying to understand a set of data, like when you want to know the likelihood that a certain person will vote a certain way. For group data, the formula that we will use is this. In calculating the standard deviation, the first thing to do is to calculate the mean of all data points, which by adding all the data points and dividing them by the number of data points, followed by calculating the variance for each data point, which is by subtracting the mean from the value of the data point. Then square the variance of each data point and add them, divide the sum of squared variance values by the number of data points in the data, and lastly, take the square root of the quotient.
The range in statistics for a given data set is the difference between the highest and lowest values. For example, if the given data set is 2, 5, 8, 10, 3, then the range will be 10 minus 2 equals 8. Thus, the range could also be defined as the difference between the highest observations and lowest observation.
Interquartile range is the difference between the third and the first quartile. This is the example of the interquartile. There are par values between the median, lower half, the middle value is 64, which is first quartile. There are 5 values above the median, upper half, the middle value is 77, which is the third quartile. The interquartile range is 77 minus 64 equals to 13. The interquartile range is the range of the middle 50% of the data. And the quartiles are the values that split sorted data into 4 parts each with an equal number of observations.
Example for the mean deviation. Determine the mean deviation for the data values. 583497. Solution. The given data values are 58347. We know that the procedure to calculate the mean deviation: first, find the mean for the given data. Mean 583497. Divide by 6. Mean 36 divided by 6. Mean equals 6. Therefore, the value is 6. Now, subtract each mean from the data value and ignore the negative symbol if any. 5 minus 6 equals 1, 8 minus 6 equals 2, 3 minus 6 equals 3, 4 minus 6 equals 2, 9 minus 6 equals 3, and 7 minus 6 equals 1. Now the obtained data set is 1, 2, 3, 2, 3, 1. Then finally, find the mean value for the obtained data set. Therefore, the mean deviation equals 1 plus 2 plus 3 plus 2 plus 3 plus 1 equals 12. Divided by 6 equals 2. Hence, the mean deviation for 583497 is 2. Z-scores. Z-scores, also known as standard score, it calculates the number of standard deviation an observation deviates from or exceeds the mean. Z-scores transformation puts into consideration variability of a group or row scores and the value of the mean. They can use to make comparisons data even if they have been obtained from different experiments. Z-scores is the number of standard deviation there are between a given value and the mean of the set. You can calculate the z-scores by first calculating the difference between your value and the mean, and then dividing that amount by the standard deviation of the set.
The box and whisker plot, sometimes simply called the box plot, is a type of graph that helps visualize the 5-number summary. It doesn't show the distribution in as much as detail as histogram does, but it's especially useful for indicating whether a distribution is skewed and whether there are potential unusual observations or outliers in the data set. A box plot is ideal for comparing distributions because the center, spread, and overall range are immediately apparent. In a box and whisker plot, the left and right sides of the box are the lower and upper quartiles. The box covers the interquartile interval where 50% of the data is found. The vertical line that split the box in two is the median. Sometimes, the mean is also indicated by a dot or a cross on the box plot. The whiskers are the two lines outside the box that go from the minimum to the lower quartile, or the start of the box, and then from the upper quartile, the end of the box, to the maximum. The graph is usually presented with an axis that indicates the values. The box and whisker plot can be presented horizontally like in figure 1 or vertically.
Look that, I just did the example of box plot. Draw the box plot of the following: 2, 2, 3, 4, 5, 5, 5, 6, 7, 9, 12. Find the minimum value, Q1, Q2, Q3, and the maximum value. Minimum value is 2, maximum value is 12. Then the median, second quartile, is 5. Median is first quartile. 3 plus 4 divided by 2 equals 3.5. Okay. Median 3, Q3, 6 plus 7 divided by 2 equals 6.5. And therefore, minimum value is 2. First quartile is 3.5. Second quartile is 5. Then third quartile is 6.5. Wow. Good job, son. I'm proud of you. Keep it up.
Standard deviation is a measure of how spread out numbers are. Its symbol is sigma. So what is variance? The variance is defined as the average of the square differences from the mean. So to calculate the variance, we need to follow this step. Number 1, work out the mean, or the simple average of numbers. Then for each number, subtract the mean and square the result, or square the differences. Next is, then work out the average of those squared differences. So let's take, for example, you and your friends have just measured the heights of your dogs in millimeters. So the heights at shoulders are 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. Find out the mean, the variance, and the standard deviation. So your first step is to find the mean. So our answer would be mean is equals to 600 plus 470 plus 170 plus 430 plus 300 over 5 is equals to 19,705 over 5. So the mean average height is 394 millimeter. Now we calculate each dog's difference from the mean. So to calculate the variance, take each difference, square it, and then average the result. So given that this is the solutions and the equation following the formulas of the variance, our variance is 21,704. And the standard deviation is just the square root of variance. So standard deviation, sigma is equals to square root of 21,704 is equals to 147.32 or 147 to the nearest millimeter. And the good thing about the standard deviation is that it is useful. Now we can show which heights are within the standard deviation, which is 147 millimeters of the mean. So using the standard deviation, we have a standard way of knowing what is normal and what is extra large or extra small. So Rottweilers are tall dogs and Dachshunds are a bit short, right? So that's it. That's how we get our standard deviation and the variance. How to find and interpret the z-score. So again, the z-score is a way of counting the number of standard deviations between a given data value and the mean of the data set. So in this lesson, we will look at the formula for the z-score, how to calculate it, and a little more closely at this idea of counting standard deviations. So to calculate the z-score, you first find the distance from the mean and then divide by the standard deviation. So this is the formula if we label the x. Calculating and interpreting the z-score. Let's look at an example to see how to use this formula. Example, the mean score on a standardized test was 508 with a standard deviation of 42. One test taker's score was 590. Now find and interpret the z-score for this score. From the example, we have the following information. The mean is 508 and the standard deviation is 42. Therefore, the z-score is equal to 1.95. When it comes to interpreting, we should note that by subtracting the mean from a data value, we will get a negative if it is smaller than the mean and a positive if it is larger. So the sign gives the direction away from the mean. By dividing this difference by the standard deviation, we are putting this distance between the mean and the data value in terms of a number of standard deviations. Therefore, we can say the test score of 590 is about 1.95 standard deviation above the mean.
Conclusion. A collection of methods known as data management enable us to create systems, applications, and algorithms that store, handle, and analyze data. Since math is useful in real-world situations for making graphs, making tables, computing averages, and other activities. What we'll learn from our topic section on measures of variation, z-scores, and box and whisker offers pupils desire to pursue that subject. It is synthesis of skills and knowledge that are intertwined with other mathematical skills and knowledge. Knowing how to measure and calculate is the most important skill to acquire, since in a new world or state of our lives, there will be many improvements that you must participate in. By using measurements like variance, z-scores, and box whiskers, we can easily make discoveries about our own lives.